Okay, so we all know AI is getting ridiculously powerful, right? It can whip up code, generate stunning art, and answer pretty much anything you throw at it. But there's a huge catch, a really big one, that we're going to break down right now. Let's get into it.
You know that feeling when you ask an AI assistant to do something kind of complex, like plan an entire trip for you, find the flights, book a hotel near the conference, and check the weather all in one go? It starts off looking good, and then somewhere down the line, it just completely faceplants. It's super frustrating, and it points to a massive challenge in the AI world.
Yeah, way too often you end up with a total mess, when what you really wanted was that seamless, perfect plan. So what gives? Why are these multi-step, real-world tasks so incredibly hard for even the smartest AIs out there? To really get to the bottom of this, we have to look past just raw intelligence. The real problem here isn't brain power, it's reliability when an AI has to deal with the messy, unpredictable, and constantly changing real world.
I mean, think about it for a second. For a long time, the tests we used for AI were just too easy. They were set in these perfect, synthetic environments, like a fake database that never, ever changes. But in reality, tasks require juggling a bunch of different live tools. Flight prices fluctuate, code on GitHub gets updated, and web search results are different from one minute to the next. That's where everything starts to fall apart.
So to fix this, researchers needed a totally new kind of test, an ultimate gauntlet for these AIs. And that, my friends, brings us to the heart of our explainer today, a brand new benchmark called LiveMCP-101.
Okay, but first, let's get on the same page. When we say an AI agent, what do we mean? We're talking about an AI that does more than just chat. It can actually use external tools, things like web search, booking APIs, or even analyzing files on your computer. This ability to use tools is what makes them so powerful, but it's also their biggest weakness.
And that is exactly where LiveMCP 101 comes in. It is a benchmark made up of 101 genuinely difficult real-world tasks, and it's designed specifically to push these AI agents to their absolute breaking point. You can think of it like a brutal obstacle course built to find every single flaw.
And we're not talking about a simple one-trick pony test here. This thing covers a massive range of skills. For just one single request, an agent might have to search the web, do some math based on what it finds, write the results to a file, and then analyze a code repository. It's wildly complex. Okay, so how on earth do you accurately test something so dynamic and chaotic? Well, the method they came up with is actually super, super smart. Let's break down how it works.
It all boils down to 3 key steps. First, they came up with 101 complex but realistic user requests. Second, and this is absolutely crucial, they manually created a perfect step-by-step solution for every single one of those requests. And third, they run the test in this unique parallel way, which we'll look at right now.
And that perfect solution has a name. It's called an execution plan. This is the gold standard. It's the ground truth sequence of tool commands that is absolutely guaranteed to solve the task correctly. Think of it as the answer key the AI is being graded against. But here's the really brilliant part, how they deal with a world that's always changing. They run 2 agents at the exact same time. You have a reference agent that just follows the perfect execution plan, and then you have the test agent, which has to figure it all out on its own. By running in parallel, both agents are dealing with the same live up-to-the-second data, which means you can have a truly fair apples-to-apples comparison of the final results. It's genius. So, the moment of truth. They built this incredibly difficult test, and they ran the world's best AIs through it. How did they do? Well, let's just say the results were a bit of a bombshell. Get this. Even the most advanced, top-tier AI models on the entire planet failed. A lot. Their success rate was less than 60%. That's a huge gap between how smart we think they are and how reliable they actually are in the real world. And listen, we're not talking about some obscure, outdated models here. They threw the heavy hitters at this. The best of the best from OpenAI, like GPT-4, from Anthropic with Claude 3, and from Google with Gemini 1.5 Pro. And all of them struggled. So why did they fail so much? This chart gives us the answer. The number one reason, by a long shot, was something called a semantic error. Basically, this means the AI understood the literal words you said, but it completely misunderstood the intent or the meaning behind them.
It's kind of like you ask someone to get you a coffee and they bring you a bag of coffee beans. I mean, technically, they're not wrong, but it's not at all what you wanted.
Now look, all this failure might sound pretty bad, but it's actually fantastic news, seriously, because now we have a crystal clear roadmap of exactly what needs to be fixed. We know where the problems are. One really interesting takeaway from the research was this idea of token efficiency. The paper points out that open source models in particular are really bad at turning their processing power, their tokens, into correct answers. It's like they're spinning their wheels. The big commercial models got a little better with more thinking time, but the open source ones just didn't. It points to a major efficiency gap. In fact, the researchers were so thorough, they managed to categorize every single failure into what they call the 7 deadly sins of AI agents. And you can see them here. It's everything from just plain ignoring the user's requirements to getting stuck in a useless thinking loop to making technical errors like writing bad code. And of course, there's that big one, misunderstanding the meaning of the request. It's a perfect checklist for developers. And here's a perfect example of how specific this diagnosis gets. The llama models had a catastrophic failure rate, almost 48%, from syntactic errors, which is just badly formed code. And the researchers think it's because those models just weren't trained on the modern frameworks needed for this kind of complex tool use. It's a huge reminder of how important that specialized training really is.
Hey, by the way, if you like these deep dives that kind of make your brain feel bigger, you should for sure subscribe to our channel, VibeDoc. Our own in-house AI has calculated that subscribing increases your intelligence by at least 10%. Although, to be fair, it might be having a slight semantic error. You should probably click it anyway, just to be safe.
So, we'll end on this thought. For the first time, we have a really precise blueprint of why these AI agents fail in the wild. We can see their blind spots with perfect clarity. So the question isn't really if they'll get better anymore, it's how fast. How long will it be until they can plan, reason, and act, not just impressively, but flawlessly?